Hello everyone, in this video I'm going to show how to use one-way data table and two-way data table in Excel, and our case is the same. Claire wants to calculate how much is going to be the retirement balance after 30 years based on the saving rate, and based on saving rate is one-way data table because she could save ranging from 6% to 15%, and she also wants to know based on the return rate, what is going to happen to the retirement balance after 30 years. For saving rate, we will use one-way data table, and when we calculate the retirement ending balance, both changing the saving rate and return rate, we will use two-way data table. So to understand the impact of varying saving rates on the retirement saving at the end of 30-year period, we will use the one-way data table. The first step in constructing a one-way data table is to list the variable to manipulate and substituting values for the variable. So we are going to enter here the column heading saving rate on I3. And then enter the saving rates 6% to 15%. So we can just write 6 and 7 and then select both and drag down this until 15%. And as you see here, the increments are 1%. The second step in constructing a one-way data table is to reference the cell or cells that contain the formula or formulas for the output you are interested in. The data table requires that the first formula reference is entered in the cell that is one row above and one column to the right of the first substitution value. If more than one formula reference are used, the subsequent formula references need to be entered in the columns to the right and on the same row as the first formula reference. So therefore we are going to enter here cell J3, and therefore we are going to enter here G41. And what is G41? It's the ending balance of the retirement account after 30 years, and we enter. And then we are going to select the data range from I3 to J13, and then next we will click on data, and under data we have what if analysis, and click on it and we will choose data table. The data table dialog box asks you to enter a row input cell or column input cell which contains that original value that will be replaced by the substitution values. Because we listed the substitution values in a column, as you see all saving rates are in a column, we will enter the cell reference of the original value as the column input cell here. And therefore we are going to enter C5 here, column input cell, and C5, which is the cell reference for the saving rate value, as the column input cell, and then we click OK. Excel completes the one-way data table by computing the ending balance for different saving rates, and you can verify that the retirement savings at the end of 30 years may range from 583,350.01 to 1,108,365.02 depending on Clary's saving rate. And please note that the column heading for the retirement saving, as you see here, is the ending balance with the original saving rate of 10%. This can be confusing to future users or the retirement calculator. To replace it with the more meaningful column heading, which is balance after 30 years, we are going to select J3, which is the cell where we have the ending balance, and then right click and we will choose Format Cells, and we will choose here Custom, and we are going to type here with quotation marks, double quotation mark, balance after 30 years, again double quotation mark, and then click OK. And make sure that you enter the double quotation marks with the column heading. And then now we have the data here, but we can continue to format these cells to make sure all of them has a $sign. Format cells, and we will choose currency, 2 decimals, and click OK. And one more time we can choose currency and click OK. And to view the combined effect of both saving rate and return rates, we will construct a two-way data table. The leftmost column of a two-way data table contains the substitution values of the first variable, whereas the top row consists of the substitution values of the second variable. In this case, we list the saving rates 6% to 15%, in cells I-17, 6%, to 15% in cells I-17 through I-26 with 1% increments. And we list the return rates 5% to 10% in cells J16, here 5%, J16 through O16 with 1% increments. And we are going to refer the first column here as saving rate. And the return rate is going to be the second row. The two-way data table requires that the formula reference of the output is entered in the cell at the top left corner. In this case, it's going to be cell I-16. So this is going to be the formula where we are going to enter it, which in this case, it's going to be G41. And G41 is the balance at the end of the 30-year period, and we enter. And then we select the range of the table, which in this case, range of the table starts from I-16 to here, which is O26. And then we click on data and what if analysis, and then data table. In the data table dialog box, we are going to enter C7 as the row input cell and C5 as the column input cell. This tells the spreadsheet that cell C7 contains the original value of the return rate, whose substitution values are listed in the same column, and the cell C5 consists of original value of saving rate, whose substitution values are listed in the same row, and then click OK. Now the spreadsheet model computes the balances based on varying values of saving rate and return rate. The table shows that the ending balance after 30 years would range from 493,315.51 if Claire invests 6% of her salaries in a more conservative asset allocation with a projected annual return of 5% to $2,318,089 if she invests 15% of her salary in an aggressive asset allocation that returns 10% annually. The table also shows that changing the return by 1% has a bigger impact on the retirement savings than changing the saving rate by 1% due to compound interest. For example, with a fixed saving rate of 6%, if the return rate increases from 6% to 7%, the retirement saving at the end of the 30-year period would increase by $111,000 to $199.98, which is the difference from $694,649.99 minus $583,350.01, whereas with the 6% fixed return rate, if Claire increases her saving from 6 to 7%, her retirement saving would increase by only $58,335, which is a change from $641,685.01 minus $583.50.01. To format the data table to be more readable, we are going to select the cell I-16 and then we are going to choose Format Cells, again choose Custom, and here we are going to type saving rate in double quotation. And then click OK. Make sure that you enter the double quotation marks with the column heading. Enter the row heading return rate in cell J15. And then we are going to select these cells all together, and then we will choose Home, Merchant Center. And in order to make these numbers more readable, we can format them to Format Cells, and here Currency, and click OK. Now, this is how we construct a two-way data table.